systems of linear equations in two variables. When you have linear equations, those are equations of lines. A solution for a system is a point or points that make all the equations in the system true. So graphically, that would be the intersection, but if you have a couple of lines, maybe they don't intersect, maybe they do. It's possible they could look like two subtly different equations, but then when you graphed them, they actually ended up being the same line. So this is kind of a summary slide of what it would look like graphically. If you graph two lines and they are parallel, they don't hit at all, then there's no solution. And no solution is also called an inconsistent system. Well, the opposite of inconsistent will be consistent, which means there is a solution. So the question when things are consistent becomes, are the lines two separate lines? Are they independent of each other? Or are they actually the same line, which we call dependent? If they're independent, then they're going to cross in one point, and that one point is an intersection, and that is the solution. On the other hand, if they're actually dependent, then every point on that line is a solution. So there's infinitely many solutions. So not every number in the world is a solution, but every point on the line is a solution. But graphing is kind of tough to do, particularly with precision, and you'll see that in a minute. So here you have some homework problems where they don't actually ask you to solve it yet. They just ask you, is it a solution? So a solution makes everything true. So what you want to do is substitute. So if this is 1, 2, and that's your x, y, you're going to put in a 1 and a 2 for the x and y and see does it work. So this equation, 2 times 1 would be 2, 3 times 2 would be 6, and 2 minus 6 is -4. 2 times 1 is 2, plus 2 is +4. If it works in both of them, the answer is yes. Down here again, just doing a separate problem, we have an x and a y. -4 and 3. When I plug that in, I get -4 plus 6. Well, -4 plus 6 is 2. And -4 and 3, plugging them in, that becomes -4 minus 6. But -4 minus 6 is -10. So that one is not the same. That one does not check. And if one of them doesn't check, the answer is no. It has to work in all of them. So if you just need to check it, however, rather than having you check it, they're often going to have you solve it. There's 3 common methods for that: graphing, substitution, and addition or elimination. The main thing I'm going to say about this is that graphing is really hard to do with precision if you're having to do the graph by hand. And even when they show you a graph that's done by a computer or a graphing system, it can be tough to get the answer because maybe it doesn't cross at a very clear point and you're trying to guess. And you might guess a fraction like 0.5, but you're never going to guess a fraction like, 1/3 or 1/7 or something. So we generally don't graph unless they tell us to. But the best way, down here in the bottom right, the best way is just follow the instructions because they are choosing problems that work well with the instructions they're giving. So let's graph. Now you're going to see me face some real challenges. If I were doing this in a classroom, I could just draw a sketch and I could draw a line fairly straight on the board. But you know for a fact I can't do it on this system. So I've got these lines and it'll take me a minute to move them around. Now when you graph, you can graph by intercepts or by slope intercept, and I tend to do it by whatever way the problem is set up. So here I have numbers in front of all of them, so I'm going to use intercepts on this one, which means I'm going to let x be 0 and figure out what y is, and then I'm going to let y be 0 and figure out what x is. Now, I'm just going to temporarily do this, but when I let x be 0, this term just disappears. So I can focus on 2y equals -4. If I divide both sides by 2, I get -2. If I let y be 0, this term disappears. So you focus on -2x equals -4. Divide both sides of that equation by -2, and I get a +2. So I don't typically mark it out like I just did, but I want you to visualize. If you're at home, you could just put your hand over one of the terms and solve for it, and that's what we're doing. So now what I'm going to do is I've got to graph that equation by getting one of these lines to go through those points. If I go 0, comma, visualize scribbling out that 3y, so divide by 3 and I get -6. Then, if I let y be 0, well, they're both divided by 3. I may have scribbled out the wrong one a while ago, but mentally, they're both divided by 3, so I get -6 both times. So now I need to get this blue line placed in the right place. So it looks like I have a pretty decent visual of where they intersect, and this one's nice and clean. They intersect at -2, -4. So I should be able to check that in both of them. I'm just going to do that orally real quick. So plugging in a -2 and a -4, I would end up with 4 minus 8. That is -4, so that one checks. In my other one, I would have -6 plus -12, and that's -18, so that checks. One more of these. Now this one I don't want to do in that approach because it is already rearranged. So I'm just going to pretend this is +0, and I'm going to take that one and start at 0. This is the other method of graphing with a line. Put one of these ends at 0 on the y-axis, so that bottom right-hand corner, I'm putting that tip right there at 0. And then I'm going to take the other one and I'm going to move it. This is a slope of 2, which means I can go up 2 and over 1 from the 0, so I'm not doing it just yet. But if you watch my cursor, if I go up 2 and over 1, I want to get that line to cross through that point right there. And maybe what I'll do is I'll go ahead and put a dot there where I'm wanting it to cross so you can see it better. Up 2 and over 1. So that one's graphed. Now if I take this 4x over, again, I could use intercepts. You can use whatever. This one means I'm going to start at -5 on that y-axis, so I'm going to get one tip of that to go to the -5. So 1, 2, 3, 4, 5. Okay, and then I need to use a slope of 4. So putting my dots on there just so you can see it first of all. And then a slope of 4 means up 1, 2, 3, 4 and over 1. So I'm also wanting to go through that point. So what you can see here is even with me trying to be very precise, where is that solution? It looks like it's about halfway, but is it about halfway? Or is one of those lines wrong? Okay, so this is where checking is really important. You have to just kind of look at it. This is why we don't like graphing very much. This looks like it's about 2.5 over. So if x is 2.5, you could say, well, what is the y value? Well, maybe it's down here and I just didn't line them up just right. Or maybe it's halfway up, or maybe it's whatever. Well, I'm actually going to use a trick. If I feel like x might be 2.5, I can plug it in here. 2 times 2.5 is 5. But I do need to check that in my next one. So if I'm plugging it in here, -4 times 2.5 is -10. -10 plus 5 is -5. So that one actually checks. Now when you're graphing on your online homework, you will have a tool selection thing where you're going to grab a line and you can put it on there, and then you can adjust the points. You can just edit the coordinates of the points on the line to get them to go through the 2 points you've identified. Is there some way to do this without graphing? Yes, yes, yes. It requires more writing, but it's actually a lot more precise. So solve by substitution. These are the steps. And kind of going through that in that problem, first of all, I'm going to write that problem underneath just so I have a little bit more room to write. Now, when I solve for substitution, I tend to like to write them side by side. So y equals 2x, and then negative 4x plus y equals negative 5. Because I'm going to draw some lines, and it just seems like they don't look so confusing when I write them side by side. Solve for one variable in one equation. That means get one variable all by itself, so it says that variable equals. Well, if you look at this first equation, I already have y equals. So we'll consider that done. Step 2, substitute the resulting expression into the other equation. Well, the resulting expression was 2x. If y is equal to 2x, I need to replace the y in the other equation with 2x. Step 3, solve that equation for the remaining variable. So now I just have an equation that only has x in it. I can combine my like terms. Divide by the coefficient of negative 2. Negative 5 divided by negative 2 is positive 2.5. Back substitute that result. So what happens is now we know what x is. We take that result back to where we were and say y equals 2 times 2.5. Solve that, so we have y equals 5. So the last step, write the answer as an ordered pair x, y. So 2.5, comma, 5. Now it says check recommended. I'm just going to mark that off because this is the exact same problem I worked on the previous screen. And that's the same answer that we checked. Solve by substitution. Step 1, I realize you don't have those steps memorized yet. You'll have to pause it, take a picture of it, write down what those steps are. But I've got it memorized. So you get one variable in one equation, you solve for it. Which it really doesn't matter which one. It's usually easiest to do the one that doesn't have a whole lot written in front of it. But what I'm going to do first is I'm going to write these over side by side. X minus y equals negative 6. 3x plus 4y equals negative 39. Step 1, to get one variable in one equation, isolate it. So I'm going to take this x and get it all by itself. That means I'm going to add y to both sides. So as I bring that over, I'm going to cram it in right there. And I'll have y minus 6. Now take the resulting expression and substitute it into the other equation. So if x is equal to y minus 6, I'm going to replace x with y minus 6. Solve the remaining equation for the remaining variable. So I've got to distribute 3. I'm going to combine my like terms, 3y plus 4y. Add 18 to both sides. Remember, I'm adding 18, so I get negative 21. Divide both sides by 7, and y is negative 3. Now that you've really solved for the one, if y is negative 3, and this is why I like to change colors, I am going to back substitute way over here and say x is equal to negative 3 minus 6. So x was equal to negative 9. So I'm going to write my answer, xy, negative 9, negative 3. Now I'm going to check that. Now I'm going to do it orally. You could use a calculator and just punch it in and make sure it works. Negative 9 minus a negative 3 becomes negative 9 plus 3, which is negative 6. It checks there. Plugging it in. 3 times negative 9 is negative 27. Negative 27 plus negative 12 is negative 39. So it does check. There's just so much writing. The check recommended means if you don't make a mistake, you should get the right answer, but it's just so easy to make a little mistake. So what if we want to solve by elimination or addition? Elimination or addition, really, you are going to eliminate one variable when you do the addition, so it doesn't matter which way you call it. You want to make sure your variables are lined up. So x minus y, whatever they give you on the screen, copy it down. 3x, try to make sure you don't make a mistake copying it, which sounds funny, but I did that earlier today and it messed up an entire problem I was working on. Pick a variable that we're going to get rid of. You cannot pick it wrong. It's usually a little bit easiest to pick something that looks less complicated, but here I don't really see any big deal. So I'm just going to pick y. So I've chosen the variable in step 2. I want to make the coefficients opposites by multiplication. So I'm going to put little arrows out here for multiplication. If I multiply this top equation by 4, I will end up with opposite coefficients. So not just the y, though. I'm going to multiply the whole thing by 4. So I end up with 4x minus 4y equals negative 24. I'll take this equation and copy it over because I don't need to multiply it by anything, so it's just an arrow. 3x plus 4y equals negative 39. Now, we're going to add these equations, and in so doing that, one of our variables, the one we picked, is going to be eliminated because negative 4y plus 4y cancels out. So we're left with 7x equals negative 63. Oh, I don't want to leave my negative off. Negative 63. Divide both sides by 7, and x is negative 9. Now, if you go back, x was negative 9 when we worked this problem the other way. So we're getting the same answer. Now, we kind of finishing up the same. You want to back substitute. So I'm actually going to take this negative 9, now that I have that, and I am going to plug it back in to either one of these problems, but I am going to choose to plug it back into the first one because that equation looks a little bit easier to deal with. So I'm going to write it over here, though. Negative 9 minus y equals negative 6. Add 9 to both sides. Negative 6 plus 9 is 3. Divide both sides by negative 1, and y is negative 3. So I got negative 9, negative 3. Now, in this particular problem, these were probably about the same length. If you get a lot of things going on in a problem, complicated numbers, this method is actually usually a little bit less writing, but it doesn't mean that it's necessarily easier to understand. So, but they'll both give you the same one. So if it tells you to solve by elimination and you really want to solve by substitution, you can, or vice versa, because you get the same answer. Now, this says solve by elimination, and I'm going to do that, but then I'm going to point out something else also. So first of all, to solve by elimination, if you notice, these already have opposite coefficients. So don't make the world harder. Look closely at your stuff before you get going, because if I just go ahead and add those, 1/7 plus 2/7 is 3/7. And then those cancel, and I'm left with 6. Now, to divide by a fraction is the same thing as multiplying by the reciprocal. So I could write divided by 3/7, so the exact same result. So x is equal to 3 will go into 6 2 times, and 2 times 7 is 14. Now, when we substitute that back in, it's kind of nice because when I put the 14 here in this x, 1/7 of 14 is 2. So it's 2 plus 1/3 y is equal to 5. So 1/3 of y is equal to 3. So now you can, the reciprocal of 1/3 then is 3, so you can divide by 1/3. That's the same as multiplying by 3 on both sides. And y is equal to 9. So now I have my answer, 14,9. However, I'm just going to draw kind of this big highlight thing down the middle. Some people just kind of almost panic when they see fractions. I don't want you to do that. You could choose to eliminate the fractions first. I don't think it's shorter on this problem since we had opposite coefficients, but if you had a problem where there weren't opposites, you might want to do it. So I'm just copying this over. What you could do, if you chose to do that, is look at your denominators. I have a 7 and a 3 in both of them. So my common denominator is 21. So what we're going to do is multiply every single thing by 21. Totally optional, but it might help on some problems. Then, when you are dealing with a whole number times a fraction, this bottom number just represents division. So 21 divided by 7 is 3, times 1 is 3. So that becomes 3x. This one becomes 7y. And 21 times 5 is 105. Here I would get 7 will go in 21, 3. 3 times 2 is 6, so that is 6x minus 7y is equal to 21. 9x is equal to 126, and x is 14. Now, I'm not going to finish the problem because it finishes the exact same way. If you look at it, leaving the fractions was certainly less writing, but sometimes it is helpful to get rid of fractions if it's just things that aren't going to cancel and you just can't deal with it. It kind of gives you a fresh start. The same thing would be true for decimals. The common denominator here is 10. You just don't see the 10, but all of these decimals are in the 10th place. If I multiply everything by 10, before I even get going on anything else, then I just won't have decimals to deal with. So that becomes 2x minus 5y equals -7. And you can see that this one might look helped by doing this process. So then, as we talked about in the past, I want to pick one of these letters to get rid of, and it's not going to make any difference. So I'm going to get rid of y. So I'm going to multiply the top equation by 2. I can go ahead and do that. That's going to give me 4x minus 10y equals -14. But then if this is a -10y, I need this one to become a +10y. So I have to multiply it by -5. All right, so everything on this row by -5. So that becomes -25x plus 10y equals +35. Now we're ready to add. So 4x minus 25x is -21x, or even plus a negative. The -10y and +10y are eliminated. -14 plus 35 is 21. Divide both sides by -21, and x is -1. Now, once you know x is -1, you're going to substitute that back, just like we've been doing. So I always like to go back to an original, because if you go back to where you've done work, you might be plugging it into a place that already has a mistake in it. I hope not, but it's possible. So here, -1 times 0.5 is -0.5. And I have -0.2y equals negative 0.7. Add 0.5 to both sides. This one goes away. Negative 0.7 plus 0.5 is negative 0.2. Divide by sides by negative 0.2, and y is 1. So our answer is negative 1, comma, 1. And you can plug that back in and check. I've actually already done that, so that checks. So one last little thought here. What if there is no solution or infinitely many solutions? How does this actually happen? This is very similar to what we did on a previous thing. If you're solving your equations and both of your letters disappear, then you will be left with a lie. Remember, we talked about that in a different lesson. If you're solving it and what's left is just a lie, like maybe you had 2x plus 6y equals 15 and negative 2x minus 6y equals 12. Well, when you add these equations, both of your letters disappear, so you're left with 0 equals 27. That is a lie. That one is no solution. Okay, that means those lines would have been parallel if I graphed them. No solution. On the other hand, infinitely many solutions is going to leave you with the truth. But when you are solving, depending on the method you're using, you're going to end up with the same number equals the same number. So if you end up with like 4 equals 4, or if you were using elimination, it might end up that all the parts cancel, and so you have 0 equals 0. Well, in both cases, those are true statements. But this is infinitely many solutions, and you would just have to find a point on the line to be a solution. Okay? This is a picture of a homework problem where the solution to this system actually is infinitely many solutions. And while any solution can be found by finding a point on the line, when we write the solution set in set notation, you need to type or write an equation. Do not be overly thrown off by that. The equation you need to write is one of the given equations solved for y. Now, in this particular case, the first equation already has y equals, so it could just be typed into the box. However, if you had two equations where neither one of them said that, you would simply need to rearrange one of the equations for y equals mx plus b. And that's what you need to type in the blank when there are infinitely many solutions. $300,000 and it was a startup. I know that's fixed. That is not going to change. That is like the B, or the beginning cost. Think of B as beginning. And the cost to make each wheelchair. There's my key rate word. Each. Each means that I'm dealing with a rate. And so whatever is each, 400 is each. That is my M value. Now, instead of an X this time, I happened to put a W because we were talking about wheelchairs. So you could read this: the cost for wheelchairs is equal to 400 each plus the startup of 300,000. You could write a similar equation if you found out how much they were going to sell the wheelchairs for. So if they're going to sell the wheelchairs for $500 each, then the revenue would be 500 W. But there wouldn't be a startup cost for that. And that's very common because you want to find out where your revenue and your costs are going to cross paths. Because when you start a business, it always starts off costing you more than when you're actually running it for a long time, because you have to start off by getting a building, getting the machines, getting whatever materials you need. So you have to deal with that first. But then that interest point is how many of something will I have to sell, or how long will I have to do this before I start to really make a profit? Because bringing in revenue is different than a profit. So just a little tip there to help you write the equations.